Hopefully everybody had a good long weekend, well rested, ready to do some math. Or, well, if you're not ready to do some math, really. So, sorry? So, I take it sweater. All right. Hey, Jasmine. So, what we're doing today is we're going to be moving on from piecewise functions. Remember those from last week, piecewise functions. Those are whenever we break something up. And we're going to be moving on to proportional models. So, first things first that I want to do is I want to fill in the blank sentence on your sheet. But I also want you all to have a fair amount of practice today. But today is going to be, well, I won't say light on math, but it's going to be heavier on pulling context clues out of word problems. So, if you're not a fan of word problems, I'd say pay attention. We're going over Shannon. So, if you're not a fan of word problems, pay attention. I'm going to be going over how we pull the identifying information out. All right, so Shannon, Cruz, David. So, again, what we're talking about today are what are known as proportional variable models. So, a proportional model, we say that if a output, and remember an output referring to typically our y, is proportional to an input, right? Then we say that the output varies directly as the input. And again, we call this type of model a general proportional model. So we have some output or y variable is equal to our input, our x, and it varies by some constant of variation or our k value. So, what does this mean? So whenever I was going over this, I was getting a little bit confused by it, but a very, very simple way of thinking about it is that there are two general cases that we're going to be looking at. The first is what's referred to as directly proportional. And directly proportional models, very, very simply, are
directly proportionate.
Directly proportionate, but if we were to restate this, we'd just say that as one amount increases or decreases, another increases at the same rate. So, for example, let's say that we earn $20 an hour working.
What do you work? Can I work there?
What's that?
What do you work? Can I work there?
So, $20 an hour. Then, how much we earn is directly proportional to how much we work. Specifically to how many hours. Right. So that's direct proportion. So for example, in this case, our output is our pay. Our K is the number of hours worked. And our input, or sorry, no, I'm sorry. Our output is still the money we earn. Our K is $20 that we're earning. That doesn't change, it stays constant. And our input is the number of hours that we work. So how much we earn is proportional to how much we work in an ideal world. I won't get into how that actually works. Unfortunately, things are not that simple. But that's for Miss Hall to go. Alright, so the other special case that we have is what's referred to as an inverse proportional relationship. So, an inversely proportional relationship is a little bit more complicated, but simply put, it's that when one value decreases at the same rate the other increases. And the best example that I can probably think of for this is speed and time. So, for example, let's say that you're late to school, or you're trying to get to school on time, right? The faster you get there, the shorter amount, or the faster you drive, the shorter amount of time it takes to get there, right? I'm sure we're all familiar with that. God knows I was whenever I was in high school.
How did you high school, sir?
I did.
You were there on
What's that?
You were there with them?
In the interest, I will plead the fifth.
So
So-
why were you late?
Because I wanted to push things up as close to the edge as I possibly could.
Now, what were you doing the night before?
So, okay, so we're getting off track.
Listen, well, I mean,
No, Shannon. So, again, speed and time. The faster that we drive, the less amount of time it gets there. Whereas, if we were to take the slower that we drive, the more amount of time it takes to get there. So we represent that in an equation as y is equal to k over x, or x to the negative p. If we have a negative exponent, that means that we just have, so if we were to have x to the negative 2, that's equal to 1 over x squared. So that's referred to as an inverse, right? So an inverse means the opposite. And for another example of this one, let's imagine we're painting a fence, or for an example of a constant of proportionality. If we, let's say that 3 people are painting a fence. And for those 3 people, it would take them 4 hours to paint that fence. Then we can write this as y is equal to, remember y is equal to k over p, or k over x. In this case, y, our output is 4. Sorry, no, our output is 3. Sorry?
No.
I'm sorry. Okay, our output is 4. 4 hours. It takes us 4 hours to paint for 3 people to paint a fence. So we have 4 is equal to k over 3, where our input is the number of people. So that tells us then that we could solve our k by multiplying each side by 3, which tells us that it would take one person 12 hours to paint a fence. So if we were to have 2 people painting a fence, how long would it take us?
8 hours.
So 12 over 2 is 6. If we were to have 5 people, it would take us 12 over 5 hours, which isn't a clean number. If we were to have 6 people, it would take us 2 hours. If we were to have 12 people, it would take us 1 hour. So, alright, all we're looking at today are these specific types of models. Yes,
we're
Shannon?
just answering them like words.
What's that?
We're just going to answer them like that.
So, no.
Dang it. How do you get my hopes up?
All right, now we should move on to the onto our Explore section, onto our second page. And can I have somebody raise a hand and read out our first question? Yes, ma'am.
The length of the skid marks made by a car when braking is directly proportional to the square of the speed of the car when braking begins. What are the input and output for this situation? Please specify.
Right. All right, now what I want you to do is take 3 minutes and identify your output and your input in this situation. You don't need to, there's no math, just reading through the problem and identifying what changes and what does it change with. One second. So that's the question. So I have confidence. Think about it a little bit. What changes and what does it change with? Yeah. So whenever it says like the equation, so what we're going to do is we're going to write output to A, a constant push down, A the constant push So like this, is that your output or is there? Yeah. Why is the output? Exactly. Exactly. I think very, very good.
Really, really fast.
And the variable then is our speed.
It was low, my man.
So, not breaking it. So, no, it's the length of what? So what do we measure? Not measuring time. We're measuring a physical thing. Of what? Exactly. Measuring the length of our skid marks. Remember, specificity is key. Alright?
Sir, I can't finish.
You're right, you cannot. Alright, so let's come back together. Who has an answer for me on what is my output? Alexis?
The output is the length of the skid mark.
Length of the skid mark.
And the input is the speed.
Alright, 1 second. So, I shouldn't hear anybody other than Alexis right now. So our output is the length of our skid marks. And you were saying that the input?
Is the speed of the vehicle.
Our input is the speed of the vehicle. Yes, very good. Alright. Now, when it says to write an equation for the proportional model, first thing we need to identify is, do we have a direct or an inverse proportion? Direct, right. And we know that because it tells us, exactly. There is zero math involved in this problem so far. So, whenever it says to write the equation for the proportional model, We know it's going to be a direct proportion. So we know it's going to take the form y equal to k times x. And we've already identified our y and our x. Right? Our y, or our output, that's equal to the skid length. Shannon, don't make me ask again. So our skid length is equal to some constant k times the speed of our vehicle. What's that? So, and for curious, so for k in this case, I would assume, I'm not huge on cars, but in this case, k would be braking force, or something equivalent to it. Basically the strength of the brakes. So the tighter your brakes are, the quicker that you're going to stop. That is my understanding. Like I said, my understanding of cars extends to, what's that? Extends, not, okay, so I have a little bit better understanding than cars, but when I say little, I mean not much. Yes. So, but our k in this instance, if you're looking for a real world equivalent, would be basically on the force of your, or the strength of your brakes. So, the stronger your brakes are, the quicker you can stop. Yes, Shannon, thanks for raising your hand.
So for each one of these problems, we're just trying to find k?
No, not always, but a fair amount of the time we are looking for k. Or we're needing to find k to find something else. And we'll get to that though, that's a good question. But, for this problem, we have a car traveling at 30 miles an hour. So our speed, or our x, is equal to 30 miles per hour. And our y, our skid lengths, are 37.5 feet. So now we need to find k. K is equal to what? And we rewrite, so we can write our equation as being 37.5 feet is equal to k times 30 miles per hour. So, if we were to find this, we get, divide both sides by 30. 37.5 over 30. 1.25? Good.
Yeah. Wait.
So, oh, I see where, okay. And, so, I made a mistake. Just like everybody else did. That came off wrong. I made a mistake. I overlooked something. And I overlooked whenever I was reading through my problem. I thought that 1.25 sounded
Oh,
great.
it's squared.
Right. When braking is directly proportional to the square of the speed of the car when the braking begins. So, that means that our equation is actually going to be skid length is equal to k times the square of the speed of the vehicle.
So then 30 squared.
Right, so 37.5 feet is equal to k times 20 times 30 squared. 37.5 over 30 squared. What's that? 0.0417. What's that? The units would be 30 miles per hour squared. So let's see. We have feet. So that's an excellent question. Jennifer, let me do a little bit of work on that and I'll get back to you with the actual units of it. But, in the meantime, what I want you to do is to calculate this same number, is to calculate these skid marks if the car were moving at 55 miles an hour rather than 30. So, take 3 minutes to do that. Jennifer, I'll work on getting those units.
So K is.
Yes.
I always forget. You tell outside the parentheses.
For D, do we also have to square the 55 miles per hour?
What's that?
For D?
Yes.
Oh, so it's 3,781.
What is K? K is our braking constant.
Yeah, for D.
So for D, our K remains the same.
Oh,
Right. Because I'm assuming that we're using the same car with the same brakes. What's that? All right, so I cannot hear Cam. I need. All right. So I cannot hear Cam. Cam.
Okay, so see? You trying to figure that out?
So no. We already found K. So K is equal to what? We don't know. K in this case is equal to 0.0417. Right, yeah, that's how I write question marks. That's weird. I know. Whatever. The K is feet per mile per hour, so it's like, that's how many feet braking
I forgot you were here, bro.
Bro, you better
Look up,
It had already gone
you
through.
are. Hey,
No, Alexis, maybe action.
Alright, so you were able to talk in your table groups, but we need to be quieter and actually at your table.
that was my second day using it. Not able, so I can't. But now I know how to use it correctly. Like I know like what to do.
The real question.
Huh? Okay.
Everybody free.
No, but like we only need two.
Alright, so who found an answer for D? So let me hear from somebody new. Yes. Corey.
For D, 126.
126. So, do we agree or disagree?
Disagree.
Agree.
Alright, so I hear agree and disagree. Alexis, why do we disagree? What did you find?
Because when I squared the 55 times the 1.25, I got 3,781.25 feet.
So, remember what I was saying though, the 1.25 was an error because I didn't account
Oh,
for the squaring.
well, you got it wrong.
So, I agree with Corey. Good job. And we'd have 126 feet would be the approximate length of the skid marks. Assuming that a car were traveling 55 miles per hour. Alright. Now, what I want you to do is to repeat that process, but in this case we're looking at an inverse variation. So, take 7 minutes and work on this one. Figure out the input and the output and how we might write it as a proportional model. And remember, we are looking at an inverse variation. So, go back to your notes on the first page and see how might we write that. Again, you have 7 minutes to do that. And I will cold call on somebody, and it will be ran.
Why are there so many equations?
So these
Yeah, I got a clear shot. What was this?
same thing.
No, I got a marker.
T is just something. It has
Wait,
spaces.
what's up?
So you don't have to write T.
Oh, I said. I got 4 You shouldn't be talking.
So the K, yeah, K.
Go back to ball.
Right, but only for this.
Talking about this.
Oh, actually, no, so for this, oh, right, yeah. This is
See it, like on the side.
No, but everybody just go.
He didn't allow that because that thing was
Haven't done it in a day.
There's a Sharpie. I got 4 hours.
you know. You see it?
No, but I do so they kind of trip off.
Have you seen Indiana Jones?
Where is this happening?
So this is for the
Oh, yeah.
When you put it on, you get the shape. That's why. That's why. Not fair about you. It's serious piece of your
Alexis? Sir? How you guys doing? Okay, so what's your input output?
Input is this.
Input is this. What is this?
Electrical circuit varies, and then the resistance. No, wait,
No.
wait, no.
So again, write it down and then write it as an equation. So, which varies? So, if something varies, is it dependent or independent? So that makes it output or input? Exactly.
So we'll spend a lot.
So, amp is not amp the unit.
I know.
Amp the current is measured. So which what varies? What's varying? Current, right? So this thing varies based upon the current depends upon resistance.
It was right hand because I can.
Yeah.
It was right hand because I literally was so good. It was right hand.
Order can last me like 2 weeks.
It is right, but not looking at amps the unit of what? Right. So we're looking at the current measuring amps are what we measure. What's that?
Was it here last year?
I learned the right hand rule. I don't remember it, but yes.
All around.
It's 4 years, no wonder, because we all was.
It's a right hand rule.
Can't mess with the right hand.
What's our input? What's our input?
About that physics.
Noel, come here.
Oh, no. I'm the left hand guy. I'm the left hand guy, right?
That's okay.
Noel, come here. I still alone.
All we need to know is rows vary in relation to
Noel.
So we have the current, L, later, and electrical circuit varies in
That means you can draw this.
Driving his left or right?
current, what varies according to what? So does current vary Shannon. Take your seat.
I know.
Oh, yeah, but it's
Good,
okay.
good.
Yeah.
I know why.
All right, so let's come back together.
Yes, sir.
Thank you. So, who do we, or can I get somebody to raise their hand and let me know what's the output, what's my input? Genesis?
Your input is the current, and then your output is the resistance.
All right, input is current, and output, so resistance. So, do we agree or do we disagree? So I hear disagree, I hear agree. Let me hear from people who disagree. Why do we disagree? Yes, Fran.
Because the current is depending on the resistance.
Exactly. So, our input, or our x, or our independent variable, output, yes. So, anybody who did the opposite of this, you are correct. But, so our output is our y variable, or our dependent. So our output is the current, because our current varies according to how the resistance changes. So our input then is our resistance. Our output is our current. Again, I see people talk about the right-hand rule, which I vaguely recall from physics. I was honestly pretty terrible at physics. I
I
didn't.
was good on camera.
Do the right hand game.
So, right.
I was
So,
Yeah,
Right.
listen.
so
Yeah, Justin.
now, all right, let's come back together, please. Now, notice that for the second part of this problem, it asks us to write the equation for this model. But it also tells us that it has an inverse proportion. So that means that rather than using our direct proportion, where y is equal to k times x, we're instead looking for an equation where y is equal to k over x. And remember, in this case, y is equal to current, or we can represent it with the label I, because we have current of I. I can speed this up. You're always having trouble seeing it. X, in this case, is equal to resistance. Alexis, I shouldn't be talking. And resistance is labeled R. David, can I ask you to put this there for a moment, please? Thank you. So, all we're going to do is swap out each of our variables. So we're going to have in y, we have I is equal to the constant of proportionality divided by the resistance, R. So, whenever we talk about an inverse proportion, this is what we're talking about. Now, Corey had some good questions because he noticed that we have in the front sheet, whenever we're talking about our inverse proportion, we have x to the p power. So, for this last equation, our p, or our exponent, was just equal to 1. And when our exponent is equal to 1, it's just implied. We don't write it. But that's not always going to be the case. And we're going to see in the next example a situation in which we have a square, or a 2 as our exponent. And it's known as the inverse square law. So you've all had physics, right?
Yeah.
So, what's the force of gravity?
No, it's not negative, it's just 9.8 meters squared.
9.8 meters squared, right? That's acceleration of gravity. So, if we have, right, for this equation, what it's telling us, Shannon, right now. So, in this equation, it's telling us to model using the inverse square law. So, what it tells us is that the force of gravity varies inversely as the square of the distance from the object to the center of the Earth. So, take 4 minutes, or no, take 2 minutes, and write this as an equation. So, we know that it's at the force of gravity, we're representing it as F, and the object is D. How do we write this as an equation? Again, take 2 minutes and then share it out. So, Noel, we have like 12 minutes. What's that? So we're at 15 minutes. Do you really want to use the last? Alright, so you have 5 minutes. Just 1 second.
Yes, sir. Alexis.
Alright, man. Enjoy the dark side.
Alright, so gentlemen, I failed to see how exactly this relates.
Morning, she's like
The point zero
Okay, we are stretching. So, Cruz. Yes, what? So, right, but we're interested in the force of gravity and it varies, right? But, remember, it's starting to turn off. So, right, for that problem, but right now we're on the but it's the square of this. So, of course, in gravity gets weaker the further away that you get. So, gravity is, so as we get further and further away from the the force of gravity gets less and less. Okay, how you doing? So that's the acceleration. In this case, we're just looking for it. Just non-gravitational. But that's also incorrect. 9.8 meters per second squared is gravity on the Earth.
Inconsistency, that's what it is. Right there. Hey, so I'm gonna be white on one side. One side? What kind of goes on? Like,
Alright, so again, if you don't have an answer, I will be calling on somebody in 1 minute. Yeah, so, what? Right, so, you know that it varies yes, now the plane is square.
like, what should be cool?
Now, what's your right? Okay, swap out
Really?
Alright, so.
Like, I know this is off topic, but can that see me?
What's that?
Can that see me?
Not coming up now. So. Genesis? Do you have an answer?
No. I mean,
Okay, so that's okay. What do you think? How might we write an equation that expresses this gravitational force? Alexis, I'm going to ask Genesis right now.
F equals K over D squared.
K over D squared. Okay. Do we agree? Do we disagree? What do we think?
I agree.
So Corey, you agree? Why do you say you agree? Okay. So, does anybody else agree or disagree? And more importantly, can anybody else explain to me why they disagree or agree? Alright, so, you're going to answer, I ask you, raise your hand. Corey, yes?
Well, because at first I had y equals k over x squared, right?
Right.
And then I just like changed it to the f and the d. And then plus I know that the x is your input, which is the distance.
Right.
And then the y is the output, which is the force.
Okay, very good. So, give me your card, I'll get you these points for that. So, for those of you who didn't quite hear, okay, Genesis, I can get you one as well. For those of you who didn't hear that though, so the reason that we have force is equal to k over the distance squared is we express, here we are told that the force of gravity on an object, it varies inversely. So that means that we're using a inverse proportionality. And an inverse proportionally as the square of the distance, or as d squared. So basically what this equation is telling us is that as we get further and further away from the center of whatever object is exerting gravity, the weaker and weaker that gravity gets. So, think about it this way. As we get further and further away from the Earth, so if you were to go up on a NASA shuttle, for example, as you get further and further away from the Earth, what happens to gravity?
It weakens.
It weakens, right. So, that is all that this equation is telling us. It's just telling us that as we get further away from the center of mass of whatever object is exerting gravity, that force of gravity gets weaker and weaker and weaker the further and further and further away that we get. So, now, with the last few minutes of class, and this one is going to be a little bit more difficult because you're going to have to figure out, you're going to have to puzzle out and do some lateral thinking here. So, I want you to take 5 minutes and find the answer for this question. So, if a whisper has a sound intensity of 10 to the negative 11th watts per meter squared, and that's at 5 meters away from somebody, what if we are at 5 centimeters? And I want you to pay attention to the fact that our units are different here. So 5 centimeters is equal to how many meters? You need to think about that whenever you're finding your answer. So again, 5 minutes to find this right now. What's that? Yes, you may work in your group. So, 75 centimeters. What makes you, how'd you find that?
So much volume in there. I wish I had that. What do you use?
So, read through the whole question.
What specific though? Like green apple, almond.
The original one?
So reagent. So it's like the ones with like water. I'm from almond for example.
Almond.
It's an almond type of soap. It's head and shoulders almond.
I don't like to say it.
So is it directly inverse or is it? I mean, wait, is it directly proportional or is it inverse?
I have to get sent to and then I went to my insurance.
What's that? Inverse, right? So, what does that mean?
Can you notice?
Yeah, it looks more, it looks like you have a ball.
Pardon? Alright, stretching.
Cut it too short though. I was trying to make it long. I was trying to do the tips only.
Think about it. Back over.
So this is too much. That's it. You can say both.
No.
So you say inverse, how do you find inverse? So, true, we're solved that, but ultimately think about it logically, right? If somebody's with you, right, and as you get further and further away, is it easier to hear them or is it harder? So, in other words, as you get further away, so there's a distance between you and some person increases, the intensity of what they're hearing, what you're hearing from them, decreases. So we have an inverse solution. You can also puzzle that up. And it's possible that they may ask you
So
to
fake and not the real
but square. So start off with trying to write this.
That's just like this, right? Because all my kids
Oh, right. I don't get that. I see your wife and take I don't have light brown or blonde. Almost have one blonde.
Hey, just wait.
Yep.
That means you come with one finger, right? Two.
Alexis, just 1 second. Alright, first 3 up. Alright, so inverse square. So that means inverse equation, and an inverse equation looks like what? So,
Salud.
first, inverse square law, or inverse looks like what? Any context, but the inverse square,
No, there.
and x in this case,
No, not you.
right, this is a 5, so it's 5 meters, and the negative So how do you solve for k? Alright, so guess Lexus. They're 100 centimeters. Alright, so let's put that together. Alright. Quiet down. Eyes up front, please. Alright, so I should not hear any talking, and thank you. So, for this question, first thing first is I'm told that I'm trying to find, or sound intensity is my output. So I is equal to K, and it's either going to vary directly or inversely, and I'm told that it varies inversely because it follows the inverse square law. So I is equal to K over X squared which, if you think about it intuitively, so they're not always going to tell you that it's following. They're not always going to tell you what type of relationship it has. So, all right, again, I'm here and talking. So, think about it intuitively. If somebody's whispering and you get further and further away from them, is it harder to hear them or is it easier to hear them?
Harder.
So, no, it doesn't. So, Cam, Bruce. All right. So, again, you're going to have to be able to use some of this lateral thinking. You're going to have to be able to puzzle this thing out, puzzle out these relationships without them being explicitly stated for you. So, if somebody's whispering and you move further and further away from them, it's harder to hear them or easier to hear them? Harder. So, the same way, as you get further away from somebody or as your distance increases between you and somebody else, the intensity of the noise, that decreases, right? So we have an inverse relationship between the two of them. So, that's how we find our I is equal to k over x squared. So, alright, I'm going to finish this problem, and at the bell, then I will release you. But I'm going to finish this problem before you are released. So, I am waiting now for silence. So I am still waiting. Alright, so on this question, I'm told that my intensity at 5 meters is 11, or 10 to the 11th power, 10 to the negative 11th, and that's equal to k over 5 squared. So I'm going to solve for k and get 10 to the negative 11th times 5 squared. So my k, in this case, is equal to my k here is equal to 0.0419. All right, and then, so, last thing, I'm not actually going to solve the equation. I just want to point out that, again, we need to convert from 5 centimeters to meters. 5 centimeters is equal to 0.05 meters. All right, so you're free to go. I will see you all on Thursday. Well, I'll see you all tomorrow, but class on Thursday. I'll see you all tomorrow as well. Not in class.
I'm working in field kids.
Yes, I can look it up for you. So it's on time, or else I can just tell you right now if you'd be interested.
Oh, okay. Can you tell me mine too?
Yeah.
Yes.
I don't know if I'm working in the field.
Because did they say that on the list for your groups, and they'll tell you which have to hear?
It still reminds me of the...
Yes.
How about the
You are not black enough to sing that song.
What's that?
What can you get back? All people are moving.
You want me to do the BBQ tonight?
Oh yeah,
You not? No, they got the last one. What did you think? I might have 73 on it, but on my other ones, I got like
Oh, it's not going there.
ATKIS, right? Do you have another last name? Oh, never mind, there we go. So you are at Pure.
Pretty sure I'm working.
Yes, you are at Northside. You're at Northside Community Garden with me.
Community garden?
We're working. We're doing the last organic output.
oh yeah.
So no, not. Yes, go ahead.